Good afternoon. My name is Joseph Caskell. In the next 6 minutes or so, I would like to inform you on an aspect of agriculture. To start off, I would like to pose a question. When you hear drone, what comes to mind? Most of you are probably aware of drone technology. I'm sure you picture an inspiring photograph or video posted on YouTube. Maybe some of you hold hobbies in drones, but to what I hope will be news to most of you is the use of drones in an agricultural setting. When a farmer has tens to hundreds or even thousands of acres of crops, they need a fast, efficient, and reliable way of viewing these crops. Instead of walking through their entire land, which could take precious hours, they rely on aerial shots. Traditionally, farmers would pay a pilot to take videos or pictures of their crops. Then, as technology advanced, farmers were capable of accessing satellites to take photos of their plots. Before I ask you what drones are in your perspective, what drones are to the ever-growing number of farmers across America and in international territories is simple. Drones are a means of having a low-cost aerial camera platform. It can take the shape of a miniature fixed-wing airplane or more commonly quadcopters or other multi-bladed small helicopters. According to Chris Anderson of MIT Technology Review, when dealing with drones in an agricultural setting, these aircrafts are capable of achieving more tasks than recreational hobbyist drones. There are quite a few variations and modifications that can be applied. To give an idea, one can create a drone to be equipped with an autopilot that utilizes GPS, all while taking aerial photos with a standard point-and-shoot camera controlled by the autopilot functions. Some drones can complete all the flying operations from auto takeoff to landing. In the case of 3D Robotics, which is the drone manufacturing company, they create software which plans flight paths, aims for maximum coverage of crops, and controls the camera to optimize the images for later analysis without the need of a third party. These aircrafts fly on low altitudes to accomplish the necessary view of crops. This altitude could run anywhere from a few meters above the plants to around 120 meters. Interestingly enough, the reason for it only being allowed so high is because the regulatory ceiling set by the United States for unmanned aircraft operations without special clearances from the Federal Aviation Administration allows so. This gives a perspective that allows farmers to have a view that they never had before. Compared with satellite imagery, it's much cheaper and offers higher resolution. Because it's taken under the clouds, it's unobstructed and available anytime. It's also much cheaper than trying to receive crop imaging from manned aircraft. These flights can easily run $1,000 an hour. Farmers can outright buy drones for less than $1,000 each. You are probably wondering, how can this technology be as cheap and available as it is? To answer your question, look into your pockets. The arrival of drones this small, cheap, and easy to use is due largely to remarkable advances in technology. Tiny micro-electromechanical sensors, or MEMS for short, have come far and make many features possible. These MEMS devices can take the form of accelerometers, which measure and set speed, magnetometers, which measure the surrounding magnetic field, and often pressure sensors, which help show atmospheric pressure buildup or the release thereof. Other technology available is small GPS modules, incredibly powerful, fast processors, and a range of digital radios. All these components are now getting better and cheaper at an unprecedented rate. This is thanks to their use in smartphones and extraordinary economics of scale of that industry. When the availability of the hardware, the only thing left is to make it function as desired. It is commonly up to the user or manufacturer to purchase or create software. The autopilot runs specialized software, often open source programs created by communities such as Do-It-Yourself Drones, which, by the opinion of many, is rather than costly code for the aerospace industry. Let's take a look at some other facts about this. Drones can provide farmers with three types of detailed views. First, seeing a crop from the air could reveal patterns that expose everything from irrigation problems to salt variations and even pests and fungal infections that aren't apparent at eye level. Second, airborne cameras can take multispectral images, capturing data from the infrared as well as visual spectrum, which could be combined to create a view of the crop that highlights differences between healthy and distressed plants in a way that could be seen with the naked eye. Finally, a drone can survey a crop on a selected schedule. This could be every week, every day, or even every hour, combined to create a time series animation. The imagery can show changes in crop, revealing trouble spots or opportunities for better crop management. It's part of a trend towards increasingly data-driven agriculture today. Farmers are exploding with engineering milestones, which is the result of long periods of automation and other innovations, with the goal being to grow more products with less effort. Tractors autonomously plant seeds. GPS-guided harvesters reap the crops with equal and high accuracy. Top-of-the-line wireless networks store and share data on soil hydration and environmental factors for analysis. We are trying to become more rigorous in our ability to spot irrigation and pest problems and get a general sense of state of the farm every day or even every hour with the use of drones. Agricultural drones are becoming a tool like any other. They help control pests, lowering the chemical load on the environment and our food. Look at what started as a military technology may end up better known as a green tech tool. Hopefully this was enlightening and insightful. Thank you for your time and have a good day. The following are my resources that I use. Thank you.